At conceptual level, we have already used ER diagrams. See, there are various models proposed even at conceptual level also, but then ER models are very popular, and even we have ER models in syllabus. That is the reason why we are focusing on ER models, entity relationship. And again, these ER models have also been extended to extended ER models like EER. But we don't have that in syllabus, so I'm not going to talk about it. So let's go on to the next step. See, I told you that there are various levels, right? So one is conceptual level, other is representational level, and other is physical level, right? Now conceptual level is mainly useful at the requirement analysis phase. You collect the requirement and then you draw these diagrams and you show to the users, and once they say yes, everything is fine, I mean, the way we communicate with the users, we should not use any technical terms, right? So these ER diagrams are going to be very easy. So conceptual level, ER. Now let us say everything is okay at ER level and you understood the requirements completely, which means they said that yes, this is what we wanted, the users. So as a database designer, you have consulted with the end users and they said that yes, everything is fine according to the ER diagrams, right? Now you should choose one of the representational model carefully. The reason is, once you choose this representational model to design the database, see, there are two things here. One is database and other is database management system. Database means the collection of data, right? Now you are talking about how to represent the data. Once you represent the data, then we are going to use software which will help us manipulate the data, right? Therefore you have to choose exactly, or you should not make any mistake in choosing which model you want to use. Once you choose the model, depending on that, you will get the database management system, the software which will act on this. For example, see, now at this representational level, we are supposed to choose a model, and depending on whatever model we use, right, we are going to assume that our data is modeled like this. So your database will become whatever model you are using here, right? Now depending on the type of database, you are going to use the software, right, the database management system. And now every database management system, every software cannot access every data possible. Depending on the model which you have used in the database, you are supposed to choose the software. And who will provide you software? Either you can write the software on your own, right, but it's going to be very hectic. That is why what people do is they'll just design the database and then they'll take the database management system available in the market. Generally there are various open source database management systems available, as well as there are commercial database management systems available, like IBM provides you and TCS provides you. Many services companies are also providing databases these days, and even Oracle also provides you, right? So which one should you choose? The model, which data model should you choose? It is always better that you choose a data model for which there are lots of database management systems available, and the most popular database model used at representation level is relational model. Okay, relational model, it is the most popular database model used. The reason why it is becoming more and more popular is because more and more vendors are manufacturing the database management, or providing this database management system, the software itself. Initially it started with IBM. So IBM, if you use relational database here, IBM was providing System R, or various softwares are there, but the earlier version was System R. Now that System R software was the database management system software which you could easily buy. And second flexibility is after this IBM, which has initially followed this relational database and provided the database management system, later many companies started providing this management system. So the advantage you get is, if your data is in relational model and if you have bought a software and if you are not happy with that software, it will be very easy for you to just replace the software with the other software and everyone will follow the same standards. There has been standardization in this area. So what do I mean by standardization is, let us say you are having a company, and in this company you have trained some people you have trained them, investing a lot of money to access the database management system. And suddenly if you change the software, again you might have to retrain your employees, right? But then the good news about this relational database model is, if you are using relational database modeling here, relational database, then relational database management systems are available, and all of them are now having this standardization, in the sense you can learn SQL and all of them are written in such a way that they could interact with SQL, which means they are all compatible with SQL. So your users, your employees need not be trained in order to understand the relational database management system itself. They can be trained to understand SQL, and in fact SQL is designed in such a way that even the first name of SQL is not this one, it was SQL, SQUEL. Initially it was called SQL, right? And you will understand with the name itself what it really means. So SQL is structured English query language. Sometimes it is also called as simple English query. QU means query language. So what does it mean? Just in an English like language you can query your database, right? Therefore it is that simple. So all the relational database management systems are now able to understand SQL. Therefore, you need not worry about what type of RDBMS you are using, as long as you know SQL. Therefore, train your employees in SQL, and if you are comfortable with the particular RDBMS software from some vendor, go with this. Later, if you feel that that vendor is not giving you enough support, or if he is charging too much for you, you can easily move your platform to some other RDBMS without worrying about training part of your employees, right? So the popularity of relational database model is because of various factors. It is not just this relational database model itself. It is because of increasing usage. See, the more people use it, the more facilities will be added and the standardization will be done, right? And if it continuously happens, then what happens is we get more and more benefit being in the platform. That sometimes it is also called as lock-in. People are now getting logged on to this relational database. If you come up with any new model, let's say you invented any new database model, and even if you say that your database model is better compared to relational database model, people will not move on to that, because they have to have various options. See, I'll tell you this. Let us say Android is there, right? Now let us say you have invented a new mobile phone, the hardware and a new software, right? And then you said that it is better even compared to it is Android. People might not go for it, because more and more app developers and more apps are available on the Android platform, right? Similarly, you can compare this RDBMS as a kind of this Android, and maybe RDB as a kind of Android, and RDBMS as a kind of app store. Now with these many apps available, people are just logged into this because it is very convenient to use it, right? Even if you say that a new model is available and which is helpful, they will not move on to that. Are you understanding this, right? So the popularity of relational database model is not just because of the model itself. It is because of the availability, the wide variety of RDBMS software available, and moreover SQL is becoming more and more powerful. So initially SQL was proposed just to query the database. Okay, about SQL we shall discuss about it later, but what I mean to say is the SQL itself is becoming more and more powerful since its evolution. Now if you look at its evolution, SQL is able to do everything that you could possibly imagine. Initially it was just a query language. It has been developed so much that you can do everything, and now every RDBMS is providing support to SQL. And if you want to run RDBMS, you should use relational database. So it is a loop, completely loop, right? And the development is going on over and over. For the past 30 years, the most dominant database system or database modeling available is this relational database. Other than this, there are various models used, maybe in 1960s and 1970s. In 1960s and 1970s, what happened was, popularly in 1960s and 70s, IBM used to have the machines, the hardware, and there were no big competitors for IBM. There were this company called as Burroughs, And what used to happen is IBM used to invent some software, I mean write some software for IBM machines, and then this Burroughs used to have the hardware, and someone had to take the IBM code and then modify it in such a way that it used to run in this Burroughs, right? And there are only these two machines. Now even the database was also initially used on IBM machines, and it was developed by IBM itself, and they were called as legacy machines, legacy systems. So legacy means you can think of it as historical, which means very old. So earlier, before this relational database, IBM on IBM machines and Burroughs machines, the databases used were, the database models used were, one is hierarchical database and other is network database. So these two database models were also popular, hierarchical and network database. And the problem with these two are there are now there are no service providers who are providing this software for this database modeling, and so they are called legacy. So but then what happened is companies in 1960s and 70s, they have already stored lot of data in this database model, and therefore they are still continuously using it, and now there are tools being developed in order to move that particular database model into this relational model. So automated tools are available so that you can use them. So, and one more thing is, since the data is very huge, people are nowadays using this data mining algorithms and data warehousing. So what is the difference between data warehousing and databases is, in data warehousing we are going to have huge data. In databases we generally have less data, right? And if from 1960s, if you are collecting the data is very huge, right? So in those systems, even other models are popular, but at present everything is relational database. And in our syllabus we have relational database, and even if you go for any interviews or anything on database companies, they'll ask you about mainly about relational database only, right? So we shall focus only on relational database, right? So later, see, we have various levels, right? So now we have already seen what is ER model, and now we are going to see what is relational model. And later what we should do is, after designing the data model in ER model, we are supposed to convert it to relational model, right? So there are various ways to convert ER model to relational model. We shall see it. And then after relational model, we should even discuss about the physical implementation. How are we going to store this relational model into the this storage devices, right? So before going ahead, we shall discuss all the terms which are present in this relational model, understand this model well, and then convert the ER diagrams into relational model, and then we shall discuss about how to query this relational model itself using various what are the languages available for that. Actually, relational model is a theoretical or formal platform, right? And it is derived from set theory. From set theory they derive relations, and from relations they derive relational this model. And now they have even proposed some formal languages like relational algebra and relational calculus. Okay, see, relational database has been proposed. Along with this, researchers in IBM, they have also proposed some formal languages like relational algebra and relational calculus. So if your database is in relational relational database model, then you can implement relational algebra and relational calculus in order to query this, right? So popular databases, relational database management systems are using this relational model, and they are providing an implementation of relational algebra and relational calculus, which is called SQL these days, right? So in order to use this practically, what is that you are supposed to do is, you have to design it in ER model and then convert it to relational model, and then install any relational database software, management software, and you can use this SQL, right, which is an implementation of relational algebra and relational calculus, and you can use this SQL to query on the database through relational DBMS, right? So what is the relationship between SQL and relational databases? SQL runs on top of relational database management system, and whatever query you give it to the relational database management system, it is going to be converted into relational algebra and relational calculus, and it will finally act on the relational database model itself. Got it? So now let's see, it might see initially it might appear to be a bit confusing, but once we look at the examples and maybe once we understand every term which is present in this relational algebra and relational calculus and SQL, it will be very easy to understand the model itself, right? So let's look at the terms first. Okay, fine.